Hi guys, now we are going to discuss about the seismic analysis and design of the tall building. So for analyzing the building for a seismic analysis, we need to have a first open the building model as we discussed about the previous video. Now define the seismic forces. Go for define load patterns and edit the load case here. Enter as a seismic and the type as seismic force. Auto lateral load. Select our Indian code of IS 1893 2002. Add new code. And now modify these seismic force. Modify lateral load. We will be having only x direction and y direction, and x direction eccentricities and y direction eccentricities are not required for now case. Those are done for special cases. And take x direction and y direction tick mark. And as per IS 1893, we will be having zone factor, site importance factor, site type, importance factor, and response reduction factor. And this zone factor, we will be having zone factor based on table 2. From table 2, based upon our location of the building, whether it is in zone 2, zone 3, zone 4, and then 5, we will be having Z factor. As we are discussing about the building in Bangalore, it will be in zone 2. So our the seismic zone factor will be 0.1. So enter here as 0.1. And site type we are assuming it as a type 2 soil. And importance factor will be having from table 6. From table 6, based upon the importance of the building, we have importance factor. Here we are taking for all residential buildings 1. So enter as 1. And then response reduction factor. This response reduction factor also will be getting from IS 1893 from table 7. From table 7, as our building is of ordinary residential concrete, reinforced concrete moment resisting frame. So we are having response reduction factor as 3. Enter here 3 and then click OK. Click OK. And now we define the seismic load, and now we need to have load cases. So define load cases. We have already automatically seismic load is got added in load cases. Then click OK. And we need to make sure that load combinations are present. So these are the load combinations which are include dead load, seismic load, and live load. And then click OK. Now we need to analyze the building. Go for set load cases to analyze, set load cases to analyze, and then make sure that building got seismic load, model load, dead load, and live load. And then run. Wait till the building got analyzed. And now the building got analyzed. And now go for the design. Click. See, we got all the deformations of the building. Wherever you want the deformation values, go and click the pointer on the point, and you will be getting the deflection values of that particular point. Now go for design. Design, concrete frame design. View or revise the preferences. Make sure that the design code is of IS 456, and then click OK, and then go for design, concrete frame design, and start design or / check. Wait till the building got designed. Our building got designed, and let us check that every member got satisfied or not. Verify all members passed. All concrete frame passed that design check, so that we give the some values to beams and columns dimensions. Those are correct, and those are got passed by the seismic analysis. Now click OK. Now we are going to have response spectrum analysis. So for response spectrum analysis, we need to define the function of response spectrum. Go to define function response spectrum. and in that response spectrum we need to add from our code book. Take IS 1893 2016, add new function, and then for that function name it as response spectrum. And now go for seismic zone. As we are of seismic zone 2, the values got changed, and importance factor is 1, soil type is 2, and response reduction factor is 3. And then make sure that the function damping ratio is 0.05. For steel building it will be 0.02, and then click OK. Click OK. Now we need to add these response spectrum function in our load cases. Go for load cases, add new load case name, response function, and load case type response spectrum, and we need to add our response spectrum in two directions, x direction and y direction. For that, add load type is of acceleration and load name is of u1, and function is of response spectrum function, and scale factor. This scale factor is of scale factor equal to, please make note, I into g by 2r. I is of 1 importance factor, and g we need to apply this in millimeter per second square, as our units are in millimeter per second square. So our g value will be 9810, and divided by 2r. 2 into response reduction factor is 3. By calculating that, we got 1633.5, and then we need to add again in y direction response, and make sure that the directional combination type will be CQC3, and then click OK, and then click OK. Now the response function got load cases got assigned. Just unlock the load model, and then now again analyze. Set load cases to run, and here as we are running response function, just uh, let us for time being we will do not run live load case and dead load case. Now click on run now. And now our building got analyzed, and now we need to design our building. Go to design, concrete frame design, start design / check. So our building got designed, and please make sure that every section got verified or not. Verify all members passed. All concrete frame passed the design check. Then click OK. This is response spectrum function. Now we will go to see time history analysis. For time history analysis, we need to first define the time history. Define function, time history function. So for this, we will be adding our data file from the resource file. As we already have the data file, go for from file, add new function, and browse our file. Our file, example time history data. As we entered our file, and first view the file, just see how many lines the header file is of. 1 2 3 4 5 6 7 8 9. 9 files, 9 lines is of a header line. So keep here 9, and number of points per line is in our file, number of points is 1. So make it as a fixed format and enter here 10 characters and then click OK. Unlock the model. We need to define our load pattern. In seismic analysis, modify the lateral load. For time history analysis, we will be taking only in X direction and then click OK. Click OK. And again, define load cases. Delete the response spectrum and add the new load case of time history analysis. Go for time history analysis. Add our load applied in acceleration load type and its load name is U1 and function is of our given time history function and scale factor is of 1633.5. We already saw and we only have only x direction, so no need to add in another load upload case. So then click OK. Click OK. Everything got, and then now analyze, set load cases to analyze. As you saw, as it is in the previous type. Now click run now. Our building got analyzed. See, the top frame is displaced. Now we can see in another plan view. This is the deformation. Actual position is this one, but our top frame got displaced due to lateral load. So you can see those displacements as you wish. And now we are going to design our building with respect to time history analysis and go for start design / check. Wait till the building got designed. Our building got designed and let us check that every member got verified or not. Verify all members pass. All concrete frames pass the design check. So okay. Hence our design of tall building using seismic analysis is completed. Thank you.